Stars are massive, luminous spheres of plasma held together by gravity. They form from clouds of gas and dust in space and undergo a long evolutionary process depending on their mass. Here's an overview of stellar evolution. 1. Stellar formation. Stars begin in nebulae, vast clouds of gas and dust. Under gravity, the material clumps together, forming a protostar. As the core temperature increases, nuclear fusion ignites, converting hydrogen into helium and releasing energy. This marks the birth of a star. 2. Main sequence, stable phase. Once nuclear fusion stabilizes, the star enters the main sequence, where it spends most of its life. The outward pressure from fusion balances gravity, keeping the star stable. The Sun, for example, is a main sequence star, expected to remain in this phase for about 10 billion years. 3. Post-main sequence evolution. The fate of a star depends on its mass. Low-mass stars, like the Sun, when hydrogen runs out, the core contracts while the outer layers expand, forming a red giant. Eventually, the outer layers drift away, creating a planetary nebula, and the core remains as a white dwarf, which slowly cools over time. High-mass stars, these stars fuse heavier elements up to iron. When fusion stops, gravity causes a catastrophic collapse, leading to a supernova explosion. This can leave behind a neutron star or, if massive enough, a black hole. 4. Stellar remnants. White dwarfs, the leftover core of a low-mass star, slowly cooling over billions of years. Neutron stars, extremely dense remnants of a high-mass star's core, made mostly of neutrons. Black holes, if the collapsing core is massive enough, it forms a black hole, where gravity is so strong that even light cannot escape. 5. Recycling in the universe. Supernovae and stellar winds scatter elements into space, enriching future star-forming regions with heavier elements necessary for planets and life.